All right, the webinar disclaimer. This WebEx service includes a feature that allows audio on any documents and other materials exchanged or viewed during the session to be recorded. By joining this session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. Okay, where I'm going to resume from the last WebEx is on this concept called pass by value. I'll read the slide, and then if we want to discuss it, we can. Java uses pass by value to pass arguments to a method. There are important differences between passing a value of variables of primitive data types and passing arrays. For a parameter of a primitive type, such as int or double or short or long, the actual value is passed. You can conceive of it as if you are passing a copy of what was in the primitive type area in storage. Changing the value of the local parameter inside the method does not affect the value of the variable outside the method, because you're passing it a copy. For a parameter of an array type, the value of the parameter contains a reference to an array. This reference is passed to the method. Any changes to the array that occur inside the method body will affect the original array that was passed as the argument. So I'd like to go through a simple example here over in NetBeans. And it is right here. We have a simple example. We got a main method. We are initializing x to be 1, and we're creating an array of ints. The reference variable name is going to be y, and it is of length 10. First thing we're doing in this main method is we're invoking the m method, and we're passing it two parameters, x and y. X contains a value of 1. It's of the type int. And y is an array of ints. So the first parameter is an int, and the second parameter is an array of ints. Over here in the m method, it's expecting an int initially, followed by an array of ints. Inside the m method, we'll refer to the array as numbers. We will assign 1001 to the variable. This is a primitive type now. Int is a primitive type, and we're going to assign 1001 to the primitive int type number. Then we assign 5555 into the first element in the numbers array, keeping in mind that when we passed y to the m method, we are passing the reference variable name, which means we are now referencing back to the original array up here. And anything we do down here will affect the original array in the main method, referred to in the main method. Running this, we'll see that we invoke the m method, and then when we come back from the m method, x is going to be whatever the value of x is, and y sub 0 is going to be whatever the value of y sub 0 is. And we see x is still 1, even though in our called method we assigned 1001 to number, but that doesn't have any bearing upon this variable x. X is still 1. However, when we call the m method and we pass the reference variable to the y array here, now when we assign 5555 into numbers sub 0, we're really assigning 5555 into the original array, and therefore y sub 0 will be 5555. Prior to that, when we created the y array, it by default gets initialized to zeros, integer zeros. and in the M method, we overlay the default 0 with 55, 55. So the important concept is to understand that when you pass an array as a parameter or as an argument, such as in here, we're receiving this, and this y is an array. Anything done to that array will be done to the original array. Anything done to this primitive type will be done to the copy, which is whatever number is. It's a copy. So when we invoke the M method and we pass it x and y, the values of x and y are passed to the number and numbers, the corresponding variables in the M method. Since y contains the reference value to the array, numbers now contains the same reference value as to the same array. In looking at this in the stack, we do know that when you enter your main method, an activation record gets created inside the stack. So this box down here gets created, and the local variables of that method get stored in the activation record on the stack. What was the first variable? X, and it was initialized to 1. The second variable was an array of ints called y. This is a reference variable to an array. The array is not stored in the stack. The array is stored over in another area of storage called the heap. So this reference, it's a pointer that points over to the heap area in storage, which is where the array is stored. Then we invoke the M method, and that creates yet another activation record on top of the activation record for the main method, and that gets stored in the stack. And the first variable that gets stored is the number variable of type int. This gets passed in through the 1 into number. And then the second variable is an array of ints, and it's being referred to as numbers. And that comes in as a reference variable. So that's a reference, an address that gets passed over to this activation record, which in fact points over to the same area and storage in the heap. Therefore, anything done to this numbers array is really going to affect the original array referred to as y in the main method. Let's take a look at test pass array. Okay, we're going to go ahead and run this so we can see what the output looks like. And it says, before invoking the swap, the array is 1, 2. After invoking the swap, the array is 1, 2. Before invoking swap first 2 in array, the array is 1, 2. And then lastly, after invoking the swap first 2 in array, the array becomes 2, 1. So let's look at the code. We have a main method, and we are declaring and creating and initializing an array of ints. It's going to be of length 2, and the array is 1, 2. So a sub 0 contains the value 1, and a sub 1 contains the value of 2. So it says here we're going to swap elements using the swap method. Before invoking the swap, the array is A sub 0 and A sub 1, and that's where we get this output right here. Array is 1 and 2. That's before the swap. Now we're going to invoke the swap method, and we're passing it 2 arguments. The first argument is the first element in the array, and the second argument is the second element in the array. Now we're not passing arrays, we are actually passing ints. We are passing the element, not the array. And the element is of type int. So we'll look at the swap array, and in fact it is looking for 2 ints. Inside the swap method, it will be referred to as N1 and N2. And these 3 lines of code will take whatever's in N1 and put it in N2, and take whatever's in N2 and put it in N1. So it's swapping. It's a void method, so nothing gets returned. And when we come back to the swap method, passing it those 2 elements, we now report out, after invoking the swap, array is array sub 0 and array sub 1. And in fact, after invoking the swap, the array is still intact. It is array is 1 and 2. Nothing occurred to the original array. Even though we passed 2 elements in the array, we are not passing the reference variable of the array. So the original array is unaffected. Now we're going to swap the elements using the swap first 2 in array method. Before invoking the swap first 2 in the array method, we have array sub 0 and array sub 1, and that's reported down here. Now we're going to invoke swap first 2 in array, but what are we passing it? We're passing it an array. Its reference variable name is A. So this is a pointer. Beware, whatever we do in this method is now going to affect the original array up here. Down here is the method swap first 2 in array. It's receiving an array of integers. Hereafter, in this method, it will be referred to as array, and we're doing the same swap method, storing the first element to a temporary variable, then taking the second element, putting it into the first, and taking the temp and putting it into the second. And that just basically flip-flops the elements in the array. It is a void method, so nothing is being returned. However, we have changed that area in storage that is referenced using the reference variable A. So now, after invoking the swap first 2 in array, we are now going to print out A sub 0 and A sub 1, and you'll see that, yes, in fact, the 2 elements have been swapped. So keep that in mind as you're passing arrays as arguments to other methods. You're passing a reference variable, not a primitive type, which will pass the value. One is passed by reference, and the other one is passed by value. If anybody has any questions, just speak right up. Otherwise, I'm going to keep going. Let's see who joined, just to welcome the folks. We lost a few. We gained a few. We lost a few. So we still have Leah and Michael. I'm going to skip over this example, but it's essentially the same thing, keeping in mind that the stack is what stores the local variables for methods and the activation records, and they get stacked on top of one another in a LIFO, or last in, first out method or procedure. And the arrays are stored, objects are stored in the heap. And those are stored in an arbitrary fashion. And when the method is no longer processing and it returns back to the previous method, the activation record in the stack goes away until you eventually go down to the main method here. So for instance, this swap method, its activation record will go away once it returns back to the main method. And then when the main method is done processing, it gets removed from the stack as well. The heap, on the other hand, these areas in storage will be monitored by the Java virtual machine to determine whether or not any method is pointing to these objects. If nothing is pointing to an array object, the JVM will determine that, and through a process known as garbage collection, it will remove those areas in storage. It will free up that area in storage for use by other programs. Okay, next is returning an array from a method. And what we're going to do is we're going to use the reverse method to take a closer look at that. I'm going to run that. And as you can see, the output basically lists the first array as being 1, 2, 3, 4, 5, 6, and then the second list is going to be 6, 5, 4, 3, 2, 1. So it takes the first array and reverses it. Here where we're declaring, creating, initializing list 1 to be of 6 integers, and then we are invoking the reverse method on list 1, and we're going to assign the results into a list 2 array of integers. Reverse method is right here. It's expecting to receive an array of integers, and essentially what this does, it uses 2 pointers where we're going to store the result in a list in an array of integers, and result will be the same length as the list that it was passed. And we are using a for loop. We're setting I equal to 0, and j is going to be equal to the length of the array minus 1. So we're pointing to the index, the last index, using j. And we're pointing to the first index using I. We'll loop for as long as the list is long, and we're incrementing I, and we're decrementing j. And we're taking the first element in the array and assigning it into the last element into the result array. And then we loop again, incrementing I. So this will now take the second element and assign that into the second to last element in j. Incrementing I and decrementing j all the way through the loop, you'll see that results now will contain the reversal of the original list 1. And that is what the results are here. So what we're doing now is we are returning an integer array denoted right here in the return type. Then you can take that array and assign it into a similar type, data type array, such as what we did here using list 2. And then we print it out. This is nothing more than the quick for loop to print out an array. And we print them both out, and you'll see that they're reversed. I'm not going to trace the reverse method. We just kind of did that. But you could take a closer look at that to see that these elements are now going into the result array in a reverse way. I'm going to skip over the count letters in array because it's more of the same. And I'll talk about searching arrays. Searching is the process of looking for a specific element in an array, for example, discovering whether a certain score is included in a list of scores. Searching is a common task done in programming, and there are many algorithms and data structures devoted to searching, one trying to be more efficient than the next. In this section, two commonly used approaches are discussed, the linear search and the binary search. The linear search approach compares the key element, called key, sequentially with each element in the array, called list. The method continues to do so until the key matches an element in the list, or the list is exhausted without the match being found. If a match is made, the linear search returns the index of the element in the array that matches the key. If no match is found, the search will return -1. Let's look at test linear search. First thing to note here is that there are two files. Test linear search, which is the class that will contain the main method. Usually the test that contains the main method is prefixed with the word test, and then the second part of the class name is going to be the class name that it's going to test. In this case, it's linear search. And linear search looks like this. This is a class. It does not have a main method in it. It just has another method, but not a main method. The linear search method is going to return an integer. The integer will either be the index of where the key was found, or it will return -1, which means that the key was not found in the list. And this is the for loop that does that. If the key is equivalent to list sub I, we return I. We'll keep looping. And if you eventually do not find the key, it's going to return -1. The test linear search looks like this. Inside is its main method. And we have an array of integers initialized to 1, 2, 3, 4. The target, or the key, is assigned the value 3. We can then use linear search, which is the name of the class, right here, inside this default package called test linear search. So we can address this. This has visibility. And inside this linear search class is a method called linear search. Here's your linear search class, and here is your linear search method. We're passing it array and target, declared up here, array and target. So the array is the first argument, and an int is the second argument. Over here, it corresponds. We're going to get an array of ints. Hereafter, it will be referred to as list, and the second argument is going to be key. And we'll reference and we'll loop through to see if, in fact, the key is inside the array called list, and return the appropriate int value. Running this, it comes back and it finds the target 3 and was found in element 2. A 2 was returned back into result, and if result is equivalent to -1, then we say the target was not found, the target 3. Else, if it's not -1, well, then we actually have where the element was found, where the key was found, which element. So in this case, the target 3 was found in element, and whatever the result was, element 2. And here is element 0, here is element 1, and here is element 2. This is the structure that we should start using for when we start to define and develop classes such as linear search. Linear search is kind of a commonly done thing, so it's probably a good idea to create its own Java class, Java file, and then reference it. And now it can be referenced in many different from many different programs elsewhere in other packages. And the way to do that is to call it linear search, call it the class name, and then to test it, create yet a different file called test linear search, which includes the main method. Skipping over this animation, we'll now talk about the binary search. For a binary search to work, however, the elements in the array must already be ordered. In other words, an ascending sort must be done on an unordered list in order for us to perform a binary search. Assume for a moment that it is in ascending order and the array looks something like this. The binary search first compares the key with the element in the middle of the array. We have an array, and it looks as though the middle is somewhere in the middle here, and it will look to see if the key is equal to, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the middle would be like 6. 1, 2, 3, 4, 5, 6. Is that it right here? And it'll look to see whether or not it is in the middle, and if it's equal, well, then we found the key. Or we could return back and say it's lower or it's higher. And then in so doing, we're going to start splitting the array into halves and eventually narrow it down such that it will eventually hit the key in that style. Let's go through binary search. Okay, once again, we have our test class, and we have our binary search class. Over here, we have our main method, where we declare and create and initialize an array. I have it as 1, 2, 3, 4, 5, 6, 7, 8. So this has been sorted in ascending order. And the target is 9. And I can take a look to see that, yes, in fact, it's right here. So we will now invoke from the binary search class over here the binary search method inside that class, passing it array, which is an array of integers, and also a target, the target being 9 of the type int. Now the binary search method takes control, and this is the technique in which you can go ahead and do the binary search. You initialize a variable low to be 0. That's going to be element 0, index 0. And while high is equal to list.length minus 1, so now we're going to go ahead and point to how many elements were in this array? There was 11. 1, 2, 3, 4, 5, 6. There's no 7. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 elements in the array. We're looking for key 9. So the list length is 10. 10 minus 1 is 9. So the high index will be 9. The low index will be 0. Well, high, which is 9, is greater than low. That's going to be the case. 9 is greater than or equal to 0. We're going to calculate the midpoint to be equal to the low plus high. In other words, 0 plus 9, which is 9, divided by 2, integer division, is going to be 4. So mid will be assigned 4. And then we look to see if the key is less than the list sub 4, the one in the middle. If that is indeed the case, then what we're going to do is we're going to subtract 1 from the mid and reestablish a new high point. Else, if the key is equivalent to the mid, well, then we return it. We return the index where we found the key. Otherwise, we establish a new low, which is going to be 1 more than the current mid. So we add 1 to mid, and that would be 5. And then we would search for the key between index 5 and 9. And this will continue on. We'll loop this way, and you'll either find it or you'll return a, this particular expression is the evaluation of where the index, what the appropriate index should be in the event you wanted to insert this 9 into this array. So let's run this. So the target was 9 was found in element 8. Let's do a different one where we do 7, because it's not here. Running that, it says the target was not found. It would be inserted as element 7. So 0, 1, 2, 3, 4, 5, 6. It would be inserted right in here. This as element 7 is the expression negative low minus 1, which is this expression here. We take the absolute value. The negative means it wasn't found. And then we take what the result is, plus 1, and make it an absolute value, make it a positive number. And that's where you get element 7. So that's how you would test the binary search. Here is another example. Let's say we have key is going to be 11, and we have this array. And it has a total of 13 elements going from 0 to 12. We first identify or determine where is our midpoint. Well, our midpoint is going to be equal to the low index plus the high index. That's 0 plus 12 divided by 2. Integer division is going to be 6. So the midpoint is 6. And we ask, is the key 11 equivalent to 50? In fact, it is lower. So we have to reestablish a new high, which is going to be 5, which is 1 less than the mid. Now we have a new high, which is 5, a new low. Here it is down here. And the mid is going to be equal to the low plus the high. That's 0 plus 5, which is 5, divided by 2. Integer division is going to be 2. It now establishes a new mid. It asks the question, the program asks the question, is the key 11 equal to 7? In fact, it is not. It is higher. So we have to now establish a new low. A new low is going to be 1 more than the mid. And we'll be here at element 3. And we have 3 plus 5 is 8. Integer division 2 is going to give you 4 as the mid. And is key 11 equal to the mid? Yes, in fact it is, so you return the 4, the index of where you found the key. This is essentially the same thing, but in this particular case, the key is not going to be found. So it will keep halving and establishing new lows and new highs and new mids. And once it realizes that 54 is not in this array, it gets determined when the high gets below the low. And when that phenomenon occurs, then we now know that the key is no longer, it's not in this array. And what you need to do is return back 1 less than the low as a negative number, and that will indicate where the key should be inserted in the event you need to do that. And that describes that. Thankfully, for all the binary searching that's needed to be done in data processing and computer science, since it's frequently used, Java provides several overloaded binary search methods for searching a key in an array of ints, of doubles, chars, short, long, float, strings, and you can use this. It's located in the java.util package, and it's in the Arrays class. For example, the following code searches the keys in an array of numbers and an array of characters. So we have an array of ints, presumably, and you can do this and find a particular, let's say, 11 in this list just by invoking java.util, the Arrays class, and the binary search method, passing it the array, reference variable name, and the 11, and it will return a 4, which is the index of where it was found. It also works for chars. So we're passing it chars, and we're searching for a T, and it does not find that, but it will return a negative number saying it wasn't found, and then the 4 is the insertion point is 3, so it returns, the return is -3 minus 1, or -4. And that's where the character T would be inserted. Again, the binary search requires that the array be pre-sorted in increasing order. So sorting arrays, like searching, is also a common task in computer programming. Many different algorithms have been developed for sorting. In this particular case, we're going to go ahead and look at the selection sort. Essentially what the selection sort does, I'll read it from the top. The selection sort finds the smallest number in the list and places it first. Then it's locked in. Then it finds the smallest number remaining in the remaining leg of the array and places that second. And it continues on until the list contains only a single number. In this example here, it looks through the entire array and it says the smallest element is 1. So it will swap whatever's in the first element 2 with 1. Now we have 1 here and 2 over here. We have the remaining leg of the array, and we will look to swap the smallest element with this first pointer. And 2 gets swapped with 9. Now 9 is over here, and 2 is locked in place. The remaining leg of the array will look for the smallest integer and swap it with the first, and now we have 4 here and 5 there, and it continues on until you eventually wind up having a sorted array. That algorithm, that technique, is known as the selection sort. I'm going to skip over that. Oh, I made this large. There we go. So here's the selection sort. Here's an example of what we just did, so I don't need to do that again. There is another algorithm called the bubble sort. And the bubble sort is a little bit different. We have an array called A, and we have 4 elements in the array. And what the bubble sort does is it points to the first element in the array and the second element in the array. And it asks the question, is the first element greater than the second element? If in fact it is, swap the 2. And then it'll go to the next 2 elements in the array and ask the same question. And if in fact it's greater, then swap the 2. So for example, we have 3 compared to 4. Is 3 greater than 4? False. We don't swap. We go to the next. Now we have 4 greater than 2. That's true. We swap them. So now 4 goes over here and 2 goes over here. Now we have 4 greater than 1. Yes, in fact it is. So we swap them. So now 4 gets placed in the last element in the array, and we do it again. And now 4 is locked in, and now we look to see, is 3 greater than 2? It is. We swap it. So now 2 is over here and 3 is here. Now we ask the question, is 3 greater than 1? Yes, it is. Swap the 2. So 3 is over here and 1 is over here. And 4 was already put in place. So now we have 3 and 4 both put in their respective positions in the sort. Then we look to see, is 2 greater than 1? Yes, it is. Swap it. And we wind up getting 1, 2, 3, 4. Now we have an ascending sorted array using the bubble sort algorithm. The third, and there are many different sort algorithms, but the 3 that we're going to focus on in this class is going to be the selection, the bubble, and the insertion sort. The insertion sort works similarly. What you do is you lock in the first element in the array, and then you look at the remaining leg of the array and where would this element 4 get placed? Where would it be inserted in the existing locked array? And in this case, it would be inserted after the 3. Now we have 3 and 4 locked into place, and we would go to the next element, and where would we need to insert that element? That would get inserted ahead of the 3. Now we have 2, 3, and 4 locked in place, and we would go ahead and look to see where this last element, value of 1, where that would be appropriately inserted, and that would in fact be inserted ahead of the 2. So what we did mentally gets translated over into Java code, and that is how you can sort an array using 3 different algorithms: the selection, the bubble, and the insertion sort. Again, fortunately for us, we don't have to do that. We don't have to write that code for every time we want to sort something. There is a sort method in the Arrays class that we can use. Just access it using the java.util package and pass it an array, for instance, of numbers. Here's an array of doubles, and you can pass it, and it will return back the array in ascending sorted order. This also works for chars, and this sort method will go ahead, and because we're passing it a reference variable, the original array will be sorted. So you can use that array. We now know chars is sorted after invoking this sort method. As a side note, Java 8 provides Arrays.sort on a particular array called list that utilizes the multi-core processors in today's computers for much faster sorting. Clearly, that would be an appropriate usage for very, very large arrays in the hundreds of thousands or millions, the parallel sort method. There is another method, the toString method in the arrays class that you can use to print out, to return a string representing the list. Okay, the main method is just a regular method. We've discussed methods in Chapter 6, and we've discussed arrays in Chapter 7. And now we're going to look to see what has been going on inside these parentheses, which are the arguments that get passed to the main method. In public static void main, we have an array of strings, and its reference variable name is args in class A. First thing that we do is we declare and create and initialize a string array called strings, and we're populating it with New York, Boston, and Atlanta. Next, what we do is we invoke the B method. We invoke the main method in the B class, and we're passing it this array, the reference variable name called strings. Over here is the class B, and it too has a main method, but it is being passed an array of strings, New York, Boston, and Atlanta. So hereafter in this main method, it will be referred to as args. So args sub 0 is going to have New York in it. Args sub 1 is going to have Boston. And args sub 2 is going to have Atlanta. This for loop will go for the length of the args length. So it'll go for 3 loops and print out arg sub 0, New York, arg sub 1, Boston, and arg sub 2, Atlanta. Here is how you can go ahead and pass arguments to a main method as strings into a string array. To do that, for instance, in Lab 7, you're going to be asked to pass an argument to the main method in your Lab 7 main method. What you need to do is go up to Run, and then come down to Project Configuration, Customize. A dialog box will pop up, and select the Run category, and over here under Arguments, there is a character N. In this case, it's surrounded in quotes. It doesn't need to be if it's just one character, but if there are blanks or spaces in between, you would need to put it in quotes in order for it to be considered the first element in the array. So we're passing it an N in the main method in NetBeans, and that's how you would do it. Hit OK, and now this program will interrogate that argument that gets passed to it, the N, to see what it needs to do. If you were to invoke this program using the command prompt, this test main, where we have a main method, public static void main, with a string array called args, you could, in the command prompt, you could invoke the test main method, the test main class, and pass it the arguments arg0, arg1, arg2, all the way up to argn by just separating them by blanks, and your program will interrogate those arguments. Let's look at the calculator exec, which will demonstrate this. the calculator program, its objective is to perform binary operations on integers. The program receives 3 parameters, an operator and 2 integers. So the operator is the plus sign, the minus, the division, and that should be an asterisk there. If you were to be invoking this on the command prompt, you would type in Java to kick off the Java virtual machine, and then the calculator passing it the 3 parameters. Over here, I'm going to make this larger, and I'm going to go to Run, Set Project Configuration, Customize, and this dialog box pops up. I'll make sure I select the Run category, and I know it's small, but it says under the Arguments box, it says double quote 6 space asterisk space 3 close double quote. Or in other words, it's a string of 6 times 3. That is what's going to get passed to this main method. I'm going to run this, and you'll see that the results are 6 times 3 equals 18. So it calculates. Skipping over these comments, the first thing that gets checked is to see if the args.length is not equal to 1. Remember, I put in 6 times 3 with the spaces and the double quotes. So the double quotes indicates that it is 1 argument. It's a string. It's an element 0 of the args string array is going to be 6 blank asterisk blank 3. That's the very first element, element 0. If the length is not equal to 1, then we haven't done things properly. So this if will generate, if it's true, an error message, and your program will end with a system.exit with a return code 0. But if the argument length is 1, then what we need to do is establish a field to store the result of the arithmetic calculation called result. And the next thing that we need to do is we need to parse or break up the argument that got passed. And it resides in element 0. There's only one element in this array. It's argument args sub 0, and inside that area of storage is a string that is 6 blank asterisk blank 3. We need to split that on the blanks and create another string array of tokens. And the tokens will represent, in token sub 0 will be the 6, token sub 1 will be the asterisk, and token sub 2 will be the 3. Now we're looking at token sub 1, so that will be the operator, and that's going to be either the plus, the minus, the asterisk, or the / character at 0, so it's the first character. There's only one character, so it's going to look to see if it is a plus. It is not. Is it a minus? It is not. It is an asterisk. That's this asterisk here. And we are going to invoke the parseInt method from the integer wrapper class, and we are going to pass it token sub 0. It will pass it the 6. And we're going to multiply the 6 times the results of what gets passed to the parseInt method in the integer wrapper class for token sub 2. And token sub 2 is going to contain the 3. So we're essentially multiplying 6 times 3, storing it into the area called result, and then we break. Down here, we put out token sub 0, which is going to be 6, followed by a space, followed by token sub 1, which is the operator, which is the multiplication sign, followed by a blank, followed by token sub 2, which is going to be the 3, and we're going to follow that up with equals and the results, which would be 18. All right, so that is passing arguments to a main method. And that brings us to the end of the Arrays chapter. Let's see who is here, and if anybody has any questions. I just see Leah and Michael. Are there any questions? Otherwise, we can call it a night.
About the arrays, isn't it possible to put multiple arrays in one class, or it has to be good with multiple classes in different projects?
Well, you can put multiple arrays in multiple methods in multiple classes. Okay,
no,
so
I mean, is it supposed to be like multiple classes in one, or it has to be separate?
I'm not sure I'm following your question, but for instance, are you looking
like
at
the Class07A?
Okay.
Yeah, I mean, isn't it supposed to be like like instead of using 3 different arrays and 3 different sections, what if it should have been like all in one instead? But then for package, though, public class.
All right, well, in Class 7A, we had one package. It was called in Class07A, and we had 3 .java files.
Yeah,
right?
that's what I meant. What if the Java file is supposed to be all in one instead of 3 different Java files?
You can go ahead and put them all into one file called .java file and put multiple classes in that one Java file.
Oh.
But it can only have one main method.
I mean, what if I would have thought multiple main methods, or it can't do that?
Not in one Java file, no.
Oh, that's what I was about to ask. Okay.
Okay, that's the reason why we created 3 separate .java files for in Class 7, and each one of those separate .java files, those source files, had its own main method.
Okay.
Okay, but you're not restricted in the amount of arrays that you put into those. You can put in as many arrays as you want. Okay, good question, Mike. Any other questions, Mike or Leah? Okay, go ahead. What do you have, Leah? Did you have anything?
No, I just wanted to say thank you.
Oh, you're welcome. Glad to have you. Hopefully this was helpful, and I kind of go through things kind of quickly, but it's being recorded, so you can always go back and pause it and play with it and go back and redo it. And if you have any questions, you can always go to the discussion tool and ask questions in there. If there are no further questions, I'll go ahead and call it a night. Okay, so thank you both for participating, and we'll see you in class next week.